yeah, so I threw some stuff together for just ideas for what are things that we could work on over the next year or so. I have them kind of divided. There's big things, and then if I scroll through real quick, there's like smaller things. But in terms of the big things, I mean, there's over the years that I've been with the organization, there's things that people complain about all the time, and so we should try to fix those things. Like, for example, like when an HDF5 writer crashes, it can leave an invalid file. So things like journaling, right? So I put some stuff like journaling. We can hold on here for a sec. So let's see. So last several years of HDF5 development, trying to focus on HPC needs. Where do we go from here? What are the next big things that we should be working on? And I outlined in my talk yesterday stuff that I wanted to work on for the last half of the year, but that's kind of small potato stuff, right? That's just things that we're going to kind of do in the background while we're doing our other work. But what are the next directions we want to push the library into in terms of its capabilities? And so I have things in there like I have journaling, Unicode. We're poor at Unicode, especially on Windows, and that's a big problem, I think, for like when people are trying to work with like benchtop instruments that you want to export all over the world to places like India or China, because all the paths in Windows are all internationalized, and as soon as you put any Unicode characters in there, our POSIX layer, which uses the Windows POSIX layer, it doesn't handle UTF, it doesn't handle even UTF-8. So that's the thing. Maybe people here are very HPC oriented and not as interested in that, but that's the thing that people ask all the time. There's the multi-threading supports for Lifeboat is working on. Streaming, right? Streaming into an HDF5 file is not as efficient as it could be. Sparse data worked on by Lifeboat. Better support for variable length data, which may come from some of the Lifeboat stuff. Cloud storage, like what do we want to do about cloud storage things? I outlined some of the stuff that I wanted to do, at least in the last half of the year. I think that the error reporting of HDF5 is less than ideal. Like if you get a giant, you get fail, you get like a negative value from things or the bad HIDT value, and then what? Do you parse the giant error stack? And there's no uniformity to that in terms of like what errors we return when certain common things happen. Like if you ran out of memory, there's a whole bunch of different error codes that we use for that throughout the library. So I think that we should redo this so that we return a set of error values that you could do things about, like, oh, there's a file access problem, or you ran out of memory, or something like that. And then if you want to, you can still parse that stack and try to guess what's going on in there. I don't know how useful that would be for anybody who's not an HDF5 developer. But I think that's something that would be very useful to add to the library. And then in terms of smaller things.
I have a bigger thing.
Oh yeah, what do you want to add?
Well, no, I'm just saying bigger possibly like column-oriented storage things.
Like add this. Let's edit this thing here.
It might mean something like that. If you had a stream of records and you knew that in advance, kind of like chunking, right? If you knew in advance that you might want to be getting columns 2 and 5 in the future more frequently than 1, 3, and 4, you might want to store several columns and allow that subset access to the more frequently accessed columns much more rapidly. And since HDF5 is multidimensional, well, I would n-dimensionalize column into layers of multidimensional data sets.
So is that different from just making chunks columns?
I would add another dimension that I just made up layers, right? But yeah. I just didn't, before we get into the smaller things, that was a bigger thing I thought I would throw in there.
A couple comments over there.
Yeah.
Do we have to repeat the question still?
So Dana, on a journaling question, I would remind you that if you got VFD Swimmer in, get journaling out of that almost for free.
Yeah, possibly. Yep.
So sorry, my comment is also on journaling. I just want to stress the urgency of that, because at scale, the only way we can really get performance out is for us with a lot of subfiling. It means technically I can't actually read data series anymore, because what I need to do is write into individual files, make sure I don't corrupt things earlier. And if you try to open like 100 files that were written on 10,000 nodes, you're already running out of U limits. But if you manage to convince someone to increase your U limits, then you wait forever just to open the files and go back and forth between them. So it's a real limit for us.
At Livermore, we use the file image feature a lot, but we'd like to do something on a more confined basis, which I've always referred to as a memory resident group. So it's file image, but it's confined to a group. So, you know, I can basically, hey, I created this group, it stays in memory, I stick a bunch of stuff there, and when I close that group, that whole thing gets written out the file in one IO request. It's a way of basically being really efficient with a lot of small stuff. And still getting, just not having to mess around with file image and a bunch of other stuff, which is a little more complex.
It's on my mind map, but maybe not on Dana's slide.
We can keep going with the, go back to the slide here. I was gonna try to edit this, but there's no license, so we can't edit it. So that's not what we're gonna do. So yeah, so there's a bunch of other smaller stuff that I thought would be useful, so I wrote it down. Improved performance, right? It would be really nice for us to have a good performance test suite, which we don't really have. We have a couple of small, tiny programs in the library that are not like really a substitute for a real performance test suite.
They did catch that thing I mentioned to you the other day about the compound type conversion. They actually did catch it right after I noticed that I made a mistake there, but.
That's nice. That's good.
And it'd be nice to also, for us to track this and then report this on like CDash and then report it as like a graph that we make easily available online so that we can track that as we go along. We do this somewhat in the background. There's a guy who monitors it, but it's not as good as it could be. So that'd be really nice. And also like just adding like a performance section to the user guide to have a good comprehensive, you know, best practices and anti-patterns for doing performant things like small chunk sizes and, you know, chunks that work against your IO patterns and things like that. And then also too, I've mentioned this several times, is changing the library defaults to be like cloud optimized basically, which is going to be optimized for a lot of things these days. It's not 1997 anymore. It's been 25 years. We can update those.
There are also a bunch of sort of small performance optimizations I've had in mind that just haven't had the time to play around with.
I'll throw another one out, and then
Compression strategies. So, I mean, in Silo, for example, we write out for unstructured grids, we write out integer data, we write out floating point data, we write out, you know, it's this whole ensemble of different things, only some of which might make sense to apply lossy compression to. It doesn't make sense to apply lossy compression to the connectivities of an unstructured mesh, for example. So in order to manage that, we have to, turn this filter off, turn that filter on for this particular data set, and actually that percolates all the way up into the application. If there's a way to sort of, at the high level, say, this is a strategy. When you encounter integer data, I want you to do this with these parameters. When you encounter floating point data, I want you to do this with these parameters. You know, being able to articulate a whole strategy for a whole ensemble of data.
I agree, yeah, that should be a part of the performance guide.
We also talked in the past that we may have some configuration outside, so like configuration files, so users do not need to change the application to change defaults, for example, for chunking size, for properties they're using, for essentially all properties will go to, you know, that file in some easy way. So you do not need to change, you do not need to change application. What? Yeah. So that will be really, another thing that HDF does, they have, I don't remember how they call it, but for example, you have file structure with the names of links, right? And you have a file that overrides those names or whatever. It's kind of, how they call it, if anyone remembers. No, it's separate file, it's outside, but application, when the file is present, those settings override, so you will see, for example, different hierarchical structure or different names, different attributes. There was.
Sort of like that with some things, like with the vol connector, we use environment variables to switch them.
Right, but it would be useful to have like, just consume like a YAML file or something
Right.
like that.
Right,
that
right,
has- yeah.
Or every property
yeah.
would be too many environment
Right.
variables.
Yeah, that'd be useful to have.
Another big thing, encryption. Would anyone actually want the file to be encrypted? Not you, you don't count. A user community, right? Someone here saying, oh yeah, I know I would encrypt my files, right? It's some work, but you could do it, right? We could fix that.
You mean everything or?
Yeah, the whole deal. At least opt in to the whole deal.
Well, if you're encrypting the whole thing,
Why does that need to be an HDF5? It'd be more like, you want to encrypt parts of it, or?
Well, no, I mean metadata or raw data, optionally, whichever pieces you wanted went in or wherever it was in the file.
yeah, well, you could do
Any
that
part of it.
for raw data, you can do that now with a filter, right?
Well, yeah, but you know,
But, yeah.
it's not so useful without the whole deal.
Right, and that, yeah, and it doesn't apply to variable length data.
We do have filters in Synchrotron community to express that, because data, like companies running the experiments, and they're writing proprietary data, it's very important. So there are users, they are not in this audience.
Oh, no, I get it. That's why I brought it up, right?
Right,
But,
right, right.
yeah.
So
But,
also,
I mean, the labs are getting is physical security and file system permissions to dictate, you know, you cannot read this file, right? And this is just not gonna be an issue for encrypting data on a lab machine.
Yeah, I think there are collaboration scenarios within the DOE complex that you probably want encrypted.
Okay.
I'm not aware of them in detail, but I have heard.
Okay.
Yeah, and like, things like medical, right? Like, you don't want to have parts of medical records, but even then, I mean, you have to like encrypt a lot of the metadata stuff too, because, you know, if you have a group that says like, you know, sexual transmitted infection test results, right? And then like, you know, this big scan, it's like, you don't need to know anything about the scan to know that like somebody had some potentially embarrassing test happen, right? Like, so there's more that has to happen than just a simple like data filter. It has to apply to large sections of the file.
Okay, you transfer your sensitive data from secure center to some other storage, right? You will be using, internet will not encrypt data for you, so you have to. Is it enough? Okay, right, so.
Quantum machine for you.
Yeah.
And a recent DOE call, they're talking about security, so data security is important.
So I'm sorry to dribble things out, but you mentioned performance. I love the idea of a performance test suite. I really like that. And somehow being able to track performance degradation, I think I heard you say that. I think that also needs to include scaling out to maybe, you know, 1, 2, or 3 separate sizes that are run on, you know, obviously the larger the scale, the less likely you're going to have to run it because to get those resources. But I do think you need to have scaling tests.
Let's see. Oh yeah, expand data types. People have been asking for a Boolean data type, machine learning types like float 16. People have been asking for that for a long time. Just have native support for it. So there's a predefined data type. Yeah. What's that?
Complex.
Complex. Yeah. Complex. Yeah.
No, bit.
Yeah. Bit. And people have asked for. I've heard talk of like quad precision, but like there's no great way to map that to other stuff. So until that becomes like a C data type, I think that's going to be tricky for us to support. I mean, it's a GNU extension, but what's that? And we already have long double.
We support user-defined floating point types.
Very fuzzy.
Yeah, you can do your own
What the
stuff.
compiler does for you is very fuzzy.
But we have I fixed bugs recently in long double stuff that were pernicious and weird. So we definitely have that. That's good. Oh.
Go ahead.
Sort of me.
I guess on that topic, I think C23 just adopted bitint, which is an arbitrary bit size integer. And so something where that's come up for me is I have cameras that spit out 12-bit pixels. So
You can do it.
but, yeah, I think I've come across something, but it would be nice to have more direct support. But maybe we can discuss exactly what that is. So.
Yeah, that's what I was saying. As with floats, you can, in HDF5, you can define your own, atomic type, specifying the exact bit layout of everything. But
Okay, yeah.
It's just harder, right? It means that now somebody's got to delve into the construction kit and then make a whole bunch of calls, whereas if we just had it natively in there, it'd be really easy.
Great.
Put a high-level macro
And then to your comment about columns, I think Alexander had mentioned exactly that as part of when discussing maybe a new table format. But I think, as others have pointed out, this is reminiscent of Parquet or some formats like this.
Yeah, people often talk about wanting to access the individual bits, the individual parts of complex types and stuff, and so be better about doing that.
Mark, would you use a streaming interface? Do you care? Okay, yeah. You, Mark, too. No, it's both, yeah. No, if I made one, right? If we made one, like really fast append. Okay. Yeah, that's what I mean, right? Do you want it in parallel? I would target serial, but. There are limits, man. There are limits.
Of course, we would like it in parallel, but an efficient way to do it in serial would be.
I had a prototype that was like 10x. It was good.
We typically are collecting, we have data that we want to analyze basically in column at a time. But the detectors give it to us in row at a time.
Yeah. So would that pairing work really well? Like column-oriented storage with sequential append?
We do this right now in our own C++.
Right.
We did it for us after, and we pulled that.
Cool. Very good.
Yeah, improved security. I mentioned this yesterday, right? Just continued improvement of the CVE test suite and fixing the GIF tool vulnerabilities, registering with more stuff so that there's more, like the OSS fuzz people send us reports. There's that OSSF scorecard. Just more of that, I think, would be useful. And then, yeah, this is like just refactoring the library. Like, I think that it's a 25-year-old C application that has grown organically, and we all try to clean stuff up as we go, but there's definitely more room for improvement in terms of encapsulating things better and just cleaning up a lot of stuff.
There are a lot of places where you can tell the library was architected to work one way, but then as new features come in and fixes come in, they don't really work with that way anymore, and they've just kind of been bodged in there. So in a lot of cases, it would be nice to sort of completely remake everything in a way that's more logical. But it takes a lot of effort to do that, obviously.
Yeah, and then there's some things that we know are kind of slow and inefficient, like property list accesses are not fast. Yes?
Which one do you do is first? Do you fight, or do I give it to one of you? Here, ladies.
So I want to bring up the issue of HDF5 command line tools, right? So we definitely have some deficiency in them.
Oh, yeah.
And the idea of when they were first designed that you can kind of create pipeline from those command line tools and really do not need programming. If you want to experiment with HDF5 file, you can import data easily, you can modify it with repack, you can compare. are there any plans to refactor, rework the tools?
I don't have anything concrete at this time. I mean, it's a good idea, and just even cleaning up the stuff that's inside of the tools, right? Which again, many years old, been added to kind of in an ad hoc manner, and there's a lot of code duplication and things like that. But yeah, and also too, just to like expand their capabilities. We've tried to clean some of it up over time, but we haven't had.
But maybe we should ask, community, not only here, but
Yeah.
kind of with survey, what kind of tools are used and where deficiencies are.
Yeah, just for the last 2 slides, I was wondering, I didn't maybe see all updates that went with the GitHub migration, but what I found extremely successful to update like C code bases is to add more and more tooling. I mean, specifically for contribution checking. Is there already like integration for like running sanitizers on all tests all the time and clang tidy and stuff like this? Because it catches like so much these days. It's so much more robust than running wall grind with a lot of false positives on the code base.
We don't have that set up at this time. No, good.
Right. Yeah, just code formatting and regression tests. And do we still run Valgrind?
Yeah, but not via
not on GitHub.
Not on GitHub.
Yeah. So yeah, I personally migrated away from wall grind just straight into sanitizers that come with Clang and GCC. So like memory sanitizer and address sanitizer helps me a lot to catch like contributions and don't even have to look at them before these things get green. And I don't have false positives of them, so it helps a lot. Anything like, and they're hard to catch things like lifetime issues of objects and stuff are really well coded with that.
Do you catch things on those that you don't catch on Valgrind?
Yes.
Yeah.
Doesn't clang tidy work better for C++ than C? No? Same.
Now that I'm not the first person to say C++ during this section, so.
I know what's coming next. How much money you got?
Well, so there, one issue with the current C interface is that it makes idiomatic C++ error handling somewhat difficult, right? We're used to having the lifetimes of objects manage resources. So
right.
It's not easy to describe what could be different, but having a C interface that is more C++ design friendly would be a big advantage to those communities that are using C++ and are happy to be using a C library, but want to provide some wrapping around it to make it more amenable to our consumers.
That sounds good. I don't know exactly what that looks like, but yeah, I'd definitely like to make the error handling better. I know like one of the groups that has complained about the error handling we have is H5Pi, is that they want to know when something fails, like, is there something that I could do about it? And right now we don't make that easy. And they actually asked me a year or two ago there's certain lines that we have where we're making like a system call and we have like hsysco to error as the macro that we call. They asked me to never change the format of that always dumps out error no in like some thing that they can look at. And then that gives them the ability to kind of like sniff the error stack and go to the bottom and then like see the thing. And so that's kind of how they're doing it now, but that's not ideal. I want to be able to return a useful error value to people, so that's way easier.
I like the design direction you went in the slide. That I think has some good things. But I would still return -1 and then have a query to say, oh, it failed. Give me the error no first. And then if I really want to probe, give me the whole stack.
Maybe. I feel like, having like an HRT set of values, right? It would not be high because there's not, a lot of stuff would just fall into, oh, there's an internal library error. And it's like, there's nothing you can really do about any of that stuff. But when we actually touch like the system calls, like those are things that potentially people could do stuff about, like you ran out of memory or the space, yeah. And that's another thing in terms of like testing. That's something that we do not really have a good test suite for, is what happens when you run out. right? And so we should really set up like a RAM disk and just like, just throw stuff into it and then just watch it run out, right, at a certain point, just because that's, I'm sure there's a whole new set of errors that we'll have in terms of cleanup. In fact, you know, some of these CVE issues that come along, and many of them, again, are from, you know, we're reading a misparsed file, and then we do something wrong with the values that we got. Like I said, oh, there's a million filters in here, and there's one filter, and so we just sail right off the end of the buffer. But there's also some of those CVE issues we get, and some of the OSS fuzz things, those come from cleanup paths, right? That like basically in almost every internal function, we go through, we do stuff, and then at the end, if there's a problem, we jump to the end and then we clean up. And there's places in there, we don't exercise these, right? They're rarely touched. And so there's sometimes cleanup problems, and testing for that would be useful.
Yeah, turning, I think you mentioned this sometime earlier, Coverity back on would help with those.
Yeah, we went through a lot of Coverity cleanup, and I think we would actually be, given the number of things that we've fixed in the library over the past like 5-10 years, I think we'd be ready for the next level of Coverity scans, for sure. We're Valgrind clean now. We compile warning free.
I hope it's not a tangent just for the CVE bugs. I mean, I understand that we want to fix things where people can send us a file and then inject arbitrary code as we just try to read it. But I think in CVEs, they also report things like resource exhaustion, right? If someone, is that something that is even on our target? I mean, is it interesting, is it relevant? Like denial of service, for example, in opening a file.
So I mean, we get those from OSS fuzz, right? There's lots of stuff that shows up like that, and we try to fix that. I mean, there's some things I can't do anything about, but like one of the last ones that we're fixing, it's with an infinite loop in the library, and so you wind up exhausting stuff, because anybody who's got like a web service online that's consuming HDF5 files, you can crash it by just giving people crap files, and these files are small, right? It's not like you have to send them, you know, a multi-terabyte file. You can send them tiny little files that just have a metadata error in them, and just keep sending them up, and you can crash a whole person's service. So yeah, we consider those important.
Yeah, okay.
It is not my request, but I recently talked to a user who was really, he was saying that current implementation of dimension scales is really, we should do something about it. So, for example, he wanted to declare, instead of providing data space dimensions when we create a data set, just have names like HDF has. So do you have other requests from people, or everyone just using whatever we have now?
I personally have not seen a lot of stuff recently about that, but I would say that a lot of the code that's in the high-level library is not as well loved as the regular library, and we should rethink some of the things that are in there. I know that the packet table stuff that was mentioned at the lunchtime talk, like people have asked us for improvements to that for a long time.
I haven't heard much about dimension scales in a while.
Yeah.
And then CDF, Ed told me that they really, not Ed, Dennis, that they really got rid of dimension scales calls in current NetCDF. So they kind of re-implemented it themselves.
Yeah, I think that may be what people have done, is that since we didn't really put a lot of time into the high-level library, people just rolled their own.
So you said NetCDF4 isn't using the HDF5 dimension scales?
Yeah, they just rewrote their own stuff. Yeah.
Another thing that would really enable a better semantic for science has come up a number of times, is, and this sounds quirky, but I get there, attributes on data types. Because you had the ability to annotate a data type with an attribute, you could add units to the dumb things that were specific to this value. This is meters. And this field in my compound type is meters and kilograms and blah, blah, blah. And you wouldn't have this weird out-of-band stuff that was make-believe semantic stuff on the data set. Put it where it belonged on the data type.
I feel like if we did something like that and made that a part of the library, we would also want to do things like have like some kind of like standardized values for SI types and things like that.
Don't go there. It's bad. Very, very bad.
It's like 11.
No, do not. Enable, but don't provide.
So I'll ask a question, and it's basically about plugins. If I recrafted the H5Z ZFP source code for internal, to be committed internally to the HDF5 library, much like the SIP plugin currently is, and submitted a PR with tests and documentation, is that something you'd want to accept if it passed muster with you, or do you want to open that floodgate?
I think that compression stuff should be in a managed filter repository, that those should be managed separately, because as soon as we start adding that stuff to the library, you know, a lot of that stuff, it depends on external libraries, it complicates testing, it creates library dependencies. I gotta start handling that stuff in CMake and the other tools.
So fair enough. Is there a way then to, so it's an external, you say that needs to be handled somewhere else. Mm-hmm. What can you do to provide hooks so that, or some way so that as HDF5 is preparing for a release, we pass over all the plugins and make sure that whatever tests exist for them, they're actually working with that release?
Well, I think we're going to talk about this a lot in a month in Hamburg, but what I would like to see is, I'd like to see an external plugin repository that has basically, you know, maybe it's got submodules for all the other things, but then of course those could disappear. We may want to just mirror them. But if we had an official thing and then we could pull that in as like a GitHub action and then have a test suite, we could just run through all of that stuff, and that could just be something that gets, it doesn't have to run on every check-in, but it can run as like a cron job, right, that we just do. Because there's a lot of stuff that I plan to add to the CI over the next couple of months, like the VFD checks and things like that. I don't want those to run every commit. I just want them to run at night.
Yeah.
The plugin, if I have to go ask Alan exactly when he runs those, but I'm pretty sure, that we still run those.
Similarly, for the wall connectors that are external, are you doing any testing and how you're hooking them? Or?
No, that's one of the things I want to start pulling into. I mentioned that yesterday when I gave my talk, is that one of the things I really want to do, you know, to make the best possible HDF5 for E4S is to start testing like the async vol connector and the cache vol connector. And as we make the vol test suite more of a publicly visible thing, help fix any issues and stuff that arise from that.
Yeah, but the async vol and cache vol are something part of the ECP team and all those things, but they're low 5. There is also a log wall and a split wall and all those things. So how?
Yeah, we could do the same thing that we would do with the compression plugins, but it becomes more complicated because of, you know, what do things implement and how do they implement them. It becomes, I think, a little
at least some hooks that you can provide. I think there is some registration mechanism. I believe that's there.
Right. I don't even know how many of the vol connectors that are out there are even registered. Yeah, it's on the website.
Yeah.
But how many people who create a vol connector come to us and register it? Right. I'm sure there's stuff out there that I don't know about that's not listed in there.
The complaint I heard is they don't know that there is a mechanism to register, so at least...
we mentioned in all the vol documentation, because I wrote most of the vol documentation. I definitely wrote all that in there, that you should go register your thing.
Update the external pass-through vol example code, this blurb in the comment that says, hey, you know what? If you've cloned this and you're making an example from this, go register here. You know?
Change this ID number.
Yeah.
Yeah, well, change the ID number too. But
I think actually in the example stuff that I've every vol connector
actual
I've
source
created.
code.
Yes, it's
Okay.
there.
Cool. But I mean, I'm sure somebody modifies that on like day one, and then when they have a mature piece of software, a year later, they've completely.
Yeah, I asked Tom about it, and he's like, "Oh, there's a thing." And they must have. He said I registered it, and it works fine. And I said, "Well, apparently you did the right thing."
I think we've heard a little bit about JSON and various forms for various other containers, and I'm wondering if you ever thought about being able to represent an arbitrary JSON file as some kind of HDF5 data structure.
Yeah, actually, so one of the things I wanted to do, and we never had the funds to really make progress on it, was one of the things that we're lacking is we don't have an example bolt connector that implements the entire HDF5 API. And this is a problem because it's hard for us to make sure that we're doing the right thing with this, right? Like for the pass-through stuff, that's pretty easy because you can go to anything in the regular native bolt connector. But I want something that actually is orthogonal storage, so I can be sure that I'm not like baking HDF5 isms into things. And then as a test bolt connector, and I think that a JSON connector is nice because you can get a BSD licensed JSON parser that I can just build on anything. So I'm not dependent on any other library or anything like that. I can just like Jansen, I think is BSD licensed. It's like one page, just put it inside the library and build it. And so we can make a whole bolt connector of it.
Right.
But we just haven't had time.
I think at some point there was a H5 JSON project that could represent HDF5 in JSON. But what I'm talking about is actually the other way. And I think what's missing maybe is attributes having attributes. So basically descending for the attributes aren't hierarchical enough, which is a bit ironic. So I'm wondering if you have any thoughts about that, because basically you could keep nesting attributes in JSON, and you can't quite do this in HDF5, and that's becoming a challenge. You could kind of fake it, right? You create basically you create a group and you have some kind of default attribute within that group that represents a value of the group.
That changes like some semantics about HDF5.
Right.
Just for like one storage modality, like I'm probably not gonna do that.
Right. But
you have to come up with some way. Yeah. Like it's up to somebody else. If you've got something within a relational database, like I don't add relations into HDF5, you have to figure out how you want to map that into HDF5 if you want to dump relational data into an HDF5 file.
What's the best
Well, sure. So you're asking what's the best way to store a tree, and what do you mean by a tree? Could you make it in? Could you translate it into like a group hierarchy in a sensible way? Right.
Well, it depends on what you mean by best. I mean, it's never going to be.
We are good computer scientists. We know how to say it depends.
Yeah, I mean, if you're looking at like a tree in an HDF5 file, that's made up of metadata. The grouping is, I mean, yeah, those are fundamental HDF5 objects, but they're not designed to. We don't design the hierarchy to be data. So if you really wanted to store data, you would want to use the typical ways of flattening your tree and storing it in a
yeah, don't put like a binary tree of records and expect it to be a group hierarchy. That would be a nightmare. I mean, you could do it, but it just would perform like, yeah, it's bad.
And if you really wanted to store a group, if you had the HDF5 API and you wanted to use that to store like group-oriented data, like if you're looking at like social network data or something like that, then if you were doing that like in a big serious project, I would look at creating a bolt connector that connected to a graph database.
Yeah, that would work. That'd be cool.
No, I mean, just like for querying and stuff like that, it'd be so much better to just use a graph database.
Are you thinking of like a key value store, something like that? Right.
With a lot of sub-objects that all follow the same structure, then that looks like a set of HDF types potentially then, and then you could create types and maybe data spaces, or I'm sorry, data sets for all the pieces of the JSON object that fit in various of those data sets, and maybe do something useful, kind of like this, the second case of what I talked about this morning. So I guess it depends on whether it's really highly structured JSON or completely amorphous JSON.
And if you really wanted to have, group data, like your hierarchy be data, I mean, you could have different data structures in the library that were optimized for that. That's a thing that we could do. We just don't have a compelling use case with a lot of money right now.
We turn highly structured JSON into tables, so that's fine. I was just wondering if HDF5 had that notion.
So we have, when we use the parallel output, we generate a mesh, and then every time step we dump basically the same set of variables out. We have users that are used to being able to look at that file while it's being written. And I know Swimmer's not going to work for parallel for a long time, but right now they get, this is file is, whenever they try to open that, because that file is still open by the process that's writing it, they're not allowed to see anything. Is there something that can be done such that I know they are not going to see the latest data, but if there's something where they can query like a few time steps back of what's being written, or something that can be done to the HDF5?
No, you need to get the Swimmer to have to ensure that you're not looking at a corrupt file, because otherwise it'll be file metadata that points off to garbage.
Well, if you don't have to keep extending the data set, then it can work, because you can have the writer write independently and the MPI, and then the readers read independently. If they get zeros or whatever the fill value is, they can assume it hasn't been written yet. I mean, it's not perfect. You have to have the full length of the data allocated at the start.
We had a way where problems in the data cache.
Right.
We had a way of like, this won't work very well. Signal to the process that says, hey, look, you get the magic HDF5 signal. Everybody go flush.
Right.
And pause until I send you the next signal. Right? Do you think that might be a very crude?
Possibly, yeah. They don't need, like, they're fine if it's 4 time steps behind, or the last time step is not complete yet or something, but they're dumping like
half the metadata might not be there for even 4 time steps back.
Okay, yeah, possibly.
The capability to use it didn't have to know about it. They had a little command line tool, and they said do the magic, and
Right.
then HDF5 did the magic, and they undo the magic.
Yeah, I think that would be better than what we have now, I guess, so.
Yeah, it would be a lot.
And the other is related to the journaling you said. I know back at the time when NetCDF was putting HDF5 underneath, one of the things Sandia funded was journaling, and nothing ever came from that. So do you think you can do a better job now, or you learned from that, or we put a lot of money into journaling and nothing ever came out because it was unsolvable, or something happened. I don't know what it was, but we know how to solve that now.
That was going on right when I joined. Yeah. John and Quincy.
Yeah, they're here.
Get that working in parallel. We simply need to get a parallel version of the page buffer going. That's a few months' work. So it's a matter of deciding to do it, frankly.
Yeah, that's.
I'll run.
What else? Let's see.
I like the remote control idea.
Yeah, more automation, more transparency. That's what I've gotten there.
Hammer.
3 marks of opinion.
25 minutes.
Which mark? So I think we've heard a lot about wall connectors. It's really exciting that there's a lot of flexibility. But I noticed that this is starting to move us away from HDF as a file format and maybe starting to emphasize the data model and more so the API a bit more.
Yeah, that's right.
How do you see that evolving into the future?
Hard to say. I mean, I think that like if you're going to archive stuff, you should archive stuff in the native file format, because that's the thing that we support and that will probably have the longest future. But in terms of like, if you have stuff and you like the HDF5 data model, your tools use it, then I think it's a very useful thing to be able to map what you're doing to an underlying data store that is more efficient for that.
it makes it easy to switch between the fast, newfangled data stores and the supported HDF5 file format using the same API.
And I believe maybe one of our keynote speakers mentioned HDF6 as opposed to HDF5 2.0. Well, but it's kind of a question, like so when does it become HDF6? And when
I would say that if we, I
2.0?
mean, the big difference between HDF4 and HDF5 is just the data model change. And so right now, I don't really see a compelling need to change the data model in such a way that we would consider it a completely new thing. In terms of the library, like if we went through and we refactored the library and made major changes to it, but essentially kept the data model and the API was pretty close, I would just call it HDF5 2.0, and that would just be a kind of a break with some of the stuff from the past. And I think that we're at the point where we need to do that. It's been 25 years, there's some stuff baked into the API that's maybe not the best idea. And so we should go through and clean some stuff up. But yeah, and the 2.0 would be more a signifier that like, hey, you're probably gonna need to change your code now, right? That this is something that's gonna be a little harder for us to just wrap a compatibility macro around it. I don't see like anything becoming HDF5.6 in the future. I think that what you might see in, I'm sorry, HDF6. But yeah, I think you'll find like HDF5 2.0 in the next couple of years where we go over the library and clean a bunch of stuff up.
Is there a potential future where the default wall connector is producing a completely different file? Because I think we've talked about changing default settings and things like that, but is there some point where maybe we have a completely different file format?
File
using
drivers can mess with the file.
Yeah.
Stripe it, as we've talked about with subfiling, stripe it across different files or separate the metadata and raw data, things like that. In terms of completely changing it,
Micro versioned in a way that allows us to update it as
Yeah. What you would find, I think, is like if we came up with more efficient data structures on the file to do modern things, then you'd wind up with file format version 4, and we would still be able to read the old data. I mean, that's an important mission. An important part of our mission is to be able to read old data, right? And as soon as you start taking that away, then I mean, that's why we still let people read like the data structures that don't have checksums. I mean, that's where a lot of our CV issues came from. And so we didn't remove those because that would make a lot of people very upset. So they're still there. I do think we need to stop creating that stuff by default. I think that you still get that by default when you create a file. If you don't set a version, you're going to get the 19, you're going to get the 1.6 API basically.
Okay. I think
we're out of time.
We're out of time. Yeah, great question. Thanks a lot.